Hi, with this video we will discuss several examples of how to determine the future value of ordinary simple annuities. Below here what you see is an ordinary simple annuity, a time diagram of an ordinary simple annuity with payments of R dollars at the end of every interest period. And an ordinary simple annuity has payments made at the end of every interest period. For any annuity, there are a total of N payments over the term of the annuity. And following the time diagram, you can see that we have the focal date for the future value. And the focal date for the future value is always on the same date as the date of the last payment. The formula for the future value of an ordinary simple annuity is the payment size. Instead of using R, we'll use PMT since that corresponds to the payment in the BA2 Plus financial calculator. We'll take the payment size and multiply it by the annuity factor for the future value. That's an accumulation factor and has a positive exponent because the focal date is in the future. That includes the accumulated value of all of the annuity payments plus the accrued interest. So it's the payment size multiplied by the factor of 1 plus I to the exponent n minus 1 divided by I. Remember that n is the number of payments in the annuity, PMT is the payment size, and I is the interest rate per payment period. You will also note that you have several built-in functions on your financial calculator, and if you explore the calculator functions, you will see that there is a row of keys devoted to annuities. If you see the words PMT or function PMT on your calculator, it has to do with the payment size of the annuity. FV has to do with the future value of the annuity. N is always the number of annuity payments. IY is the nominal interest rate. You will enter the interest rate using the IY function, and then in order to enter the compounding periods per year and the payments periods per year, you will have to enter second function IY to access the CY and the PY functions, which are compounding periods per year for CY, and PY stands for the payment periods per year. It's very important to note how often the payments are made in an annuity, what is the annual frequency of the payments, as well as how the interest is calculated with the annuity that you are working with. Let's take a look at the first example. A person deposits $2,500 at the end of every quarterly period for 5 years. Determine the accumulated value and the earned interest at the end of the 5th year if the deposits earn 11% compounded quarterly. First of all, let's analyze what we know. We have a regular annuity of $2,500 paid at the end of every quarterly period. So my payment size, PMT, is equal to $2,500 per quarter. In addition to that, I also know that the interest rate is 11% compounded quarterly. So 11% compounded quarterly means that the interest rate, I, is equal to 11% divided by 4, or 2.75% per quarter. And I also know that I'm going to be making these quarterly deposits for a period of 5 years. So from 0 to 5 years, I like to draw a time diagram here. So from 0 to 5 years, I'm going to be making 1, 2, 3, there's 4 deposits per year. I'm going to be making a total of 20 quarterly deposits of $2,500. So every payment is $2,500. So here is your regular, ordinary, simple annuity. And I'm going to draw an annuity bus around this and say, here's our annuity bus. The first payment is at the end of the first quarterly period, and the last payment is at the end of the 20th quarterly period. And the question is to determine the accumulated value and the earned interest at the end of the 5th year. So I'm looking at the future value of this annuity of 20 quarterly deposits. And you'll notice that I drew my focal date at the end of the term of the annuity, and I want to determine the final value of the annuity, which includes all of the deposits plus the accrued interest on all the deposits. And I'm going to use the final value formula, which is a product between the payment size, $2,500, and the annuity factor. The annuity factor for the final value is 1 plus the interest rate, which is 1.0275, raised to the exponent n. In this case, n is 20 deposits. The n corresponds to the number of deposits in the annuity, less 1 divided by the interest rate, which is 0.0275. And notice that this payment size is per quarter, and the interest size rate is per quarter, and they both coincide. For an ordinary simple annuity, the payments and the interest period must coincide. And when we multiply those two numbers out on our calculators, we'll end up with a final value on our calculators of $65,493.49. And so we can indicate that the maturity value or the final value is $65,000. So final value is equal to $65,493.49, and that allows us now to compute the earned interest for the 20 deposits. Common sense tells us that the earned interest is simply the difference between what went into the savings account and what is the value at the end of the term. So in other words, it's the difference between the money in and the money out. The maturity value is $65,000. The total value of the deposits is 20 multiplied by $2,500 per quarter, or a total of $50,000, and the difference between the two is the interest. So the interest then is going to be equal to $65,493.49 less the $50,000, or in other words, $15,493.49. So the interest over the 5 years is $15,493.